Hey everyone, and welcome to our engineering webinar series. We hope that you, your family, and colleagues are all safe and healthy during these challenging times. My name is Walter Cotto, and I'm a customer consultant here for the U.S. Academic West. I'm going to be your moderator for today's session, so it's my pleasure to introduce Matteo Cagaris, my colleague here at Elsevier, who's going to talk to us about STEAM. So before we begin, I'm going to launch a poll to see who's used Engineering Village before. And if you have any questions, please ask them in the question and answer queue, and then we'll get to those questions at the end of the session if time allows. So with that, Matteo, I'm gonna turn this over to you now.
Lovely. Thank you, Walter. So hello, everybody. My name is Matteo Caligaris, and I'm trying to change the slide. Okay, today we're going to talk about the STEAM calculator in Knovel. A quick agenda. I'm going to introduce myself, and then we're going to go on how we used to get to STEAM thermodynamic properties once upon a time. I'm going to talk about the Knovel STEAM calculator. Who's that for? Why people might use it, and then onto a quick example and a quick demo on the product. But let me get started. This is me. And I have a PhD in mechanical engineering, and I worked as an engineer for a little bit. And I was working as R&D engineer in filtration for pharmaceutical and microelectronics until I decided that I wanted a bit of a change, and I landed a job at Elsevier as sales support, which I've done for about 4 years until I became a product manager, which is what I am right now. I'm the person who talks to users and talks to scientists and engineers to understand what they need and how we can do better to serve their work and their workflow. I'm also a father of two, Giovanna and Lorenzo, and you can see us here on a very socially distant vacation this summer. So STEAM is very important in engineering and in economy because it's used just about in every industry, either as a solvent or managing heat or energy. And so knowing accurately its property is critical both for safe operation, but also for economics of processes and plants. So once upon a time, when I was in college about 20 plus years ago, this is what we used to use to find the properties of steam. This is called a Mollier diagram or psychrometric diagram, I think it's called in the United States, and it's very a very unfriendly way to get properties. You need a ruler. Most of the times you make it dirty because you have to, draw a point on it. It's very large. I want to say it's an A1, so it's about half a square meter. So it's really big, and you have to know a bunch of things and to get it. So it's not great. It's not a great way to get data. And so first we started with this, and then I graduated to discovering that at the end of my book there were tables, but these are tables that they can be found and purchased, and they're very large books, but they're not perfect as well. Maybe, and also they're not very streamlined, as in like you need to find what you need, the data you need, but also then do some kind of interpolation to get the data you want. So not ideal. Then when the next graduation, I got HP 48G Plus. This is just 48G, and it's a great calculator. It's wonderful. It has the Polish inverse Polish notation, which makes it very easy to make calculations. Someone actually created a software here that allowed people to find the properties of steam very easily. Not any of these, but I don't know how many of these are still around. It was not great either. It was very slow and didn't have everything. So what we did at Knovel, where we tried to serve engineers and scientists the best we can, was to create a calculator that allows engineers and scientists to reduce the time it takes them to calculate properties and without referring to any tables or graph or manual interpolation. These are equations that are solved on the fly by our engine that come, and the equations come from the International Association for the Properties of Water and Steam, AIPWS, which is an international nonprofit association of national organizations concerned with the properties of water and steam, particularly thermophysical properties and other aspects of high temperature steam, water, and aqueous mixtures that are relevant to thermal power cycles, and of course, all the other industries application. The cool thing is that by simply inputting a couple of parameters and conditions, one can instantly need the data they need. And it's great, and it's actually perfect, I think, for the times where quick and accurate information is needed. From the survey earlier, I know that not everybody is familiar with Knovel, so I want to show you where you can find this in Knovel. It's here in the sidebar here. You can see these more tools. These are some of the tools that you have available, and one of them is a steam calculator. Another way to find it is by typing in steam, and this will bubble up a card, show a card where you can select the type of calculation that you need and then click on any of them, depending on your needs. But to be more specific, what does the calculator, what can the calculator provide you? By inputting a selection of these 4 properties: temperature, pressure, saturation, and quality, you can find any of these thermodynamic property, ranging from density to dynamic viscosity, of course, enthalpy and entropy, but also the heat capacities, finding pressure is a function of temperature and vice versa, specific enthalpy and entropy, isobaric heat capacity, isochoric heat capacity, thermal conductivity, et cetera, et cetera, et cetera. So just about everything you need to know. In our mind, this was developed to help just about anybody that needs the properties of steam, ranging from students who need to learn more about thermodynamics related to steam and water, or for studying process engineering, where a quick calculation for classroom assignment or capstone projects is necessary. The steam calculator can help you. It also goes more on the profession, where engineers, chemical engineers, and chemists need to bring us a process to a larger scale, where for molecules, for example. Design engineers might need it when they design plants and they need calculations, or to build facilities that utilize water and steam. For EHS engineers, to ensure safety of plants during design and operation, and also to reduce accident related to steam overpressures, which can be pretty devastating. Also for, for engineers that work in operational efficiencies. In fact, according to the Department of Energy, in industrial manufacturing facilities, process heating accounts for an average of more than 60% of all the thermal energy use, which is predominantly in the form of steam. So process heating also accounts for a significant portion of controllable operating costs, and is one of the few areas of opportunity where management can reduce operating costs and improve profits. And also valuable for VPs and professional engineers to determine ROI as well as safety. We think that people can use the steam calculator for R&D purposes, from lab and pilot scales to understand operating conditions in stages before a full simulation is needed. So it's also helpful in design to derive first and second estimates, applying more complexity for localized aspects of a process plant, energy balance, flow rate in different areas of the process, for example, localized pump design, and their temperature and pressure, where in this case, probably simulation would be a bit of an overkill. It's also good for plant and safety engineers, where they need to solve localized problem, but without having to do a full simulation. So with that said, I I created a bit of an example here where we have where we can use the steam calculator and see how it can practically solve these equations. And I was thinking about a tank that lives outside, and there's water inside at 3 atmospheres. So what is the temp? So the liquid would the water inside would be liquid until the temperature reaches a certain value. And so before that value, I need to start my convective cooler here to decrease the temperature, or whatever, some cooler, just a kind of a simple drawing. So here the result is that I'm going to have to turn on this convective cooler at 133 degrees. But let's look at how we would find that number out right away. So I would be here within Knovel, and I would first of all have to log in into the correct account. So okay. And one way that I would normally do, I always try to start searching first. Oh, not Steam, but we are suggesting you to search for Steam. There you go. And this, of course, bubbles up all the different, the 8 different calculators that we have. And in this case, I need to know the saturation and quality properties by pressure. If I click on that calculator, I open the Steam calculators page. There's 8 of them, and I land on the correct one in this case. As I mentioned, I have a tank that is at 3 atmospheres, so I can easily change the value of the pressure here. Type in 3, and also I know that the quality is 0, so I want the quality to be 0. So I click calculate, and I can find a value, the values including specific volume, internal energy, specific entropy, and so on, and as well as the temperature. So I can change the value of the unit to measure the temperature for Kelvin to Celsius, and of course I land on that's 134 degrees, meaning that I would have to turn on my my cooling system at about 100. A bit earlier than that, maybe 120, to get started and decrease the temperature to prevent potentially an explosion or the activation of some safety device. And this is one example, right? And this is one way to use it. There's plenty of other properties can be calculated. I want to point out one thing, which is I can find a specific point or a specific value, but I can also look for ranges. And so if the pressure, instead having a specific value, I want a range, I want to create a table. Let's say that I want to go from 3 atmospheres to maybe 30 atmospheres. And in increments of 5 atmospheres, I can calculate this. And you can here right away find a table with what we were discussing, the value we can discuss, and you can easily copy paste this into an Excel file, and it translates really well. Let me show you. Yep, I made a mistake here. Sorry about that. All right, this didn't work as I expected, but it does work well. With that said, I want to point out a couple more things. You can find temperature, other values by prescribing temperature and quality. The compressed water and superheated steam will take pressure and temperature to give you the different properties. The metastable steam will take as well temperature and quality. High temperature steam We'll go from pressure and temperature from very high values, starting from about 1100 Kelvin. Transfer properties will accept temp as well, pressure and temperature. Dynamic viscosity and thermal conductivity will go also for temperature and pressure until we get to surface tension, which only gets the temperature. With that said, I hope this was helpful, and I'll gladly take questions if needed. Walter?
Yeah, thank you, Mateo. I'm going to launch another poll here, and then if anybody has questions, please go ahead and ask them in the Q&A section. So let's launch that. All right, Mateo. So we have one question here. Who has access right now?
Sure. So everybody has who has a Knovel subscription has access to the Steam calculator. Also, the people that only just want to go and take a look, they can go to app.knovel.com, and by doing exactly what I showed earlier, they can get to it. It's open to the public as well.
Perfect. Thank you. With that, we're going to be holding these, about twice a month now, and we're going to be sending you the new webinar schedule pretty soon. So thank you for joining us. We really appreciate it, and have a good rest of your day.
Thank you, Walter, and thank you everybody for joining, and have a good rest of your day. Bye-bye.